Hi, Mr. Corsi here. This video has the complete detailed solutions to all the questions in the AQA Foundation Level GCSE Mathematics Paper 2 exam from 2024. Now there's a lot of questions, but to find the particular question you might be interested in, you just need to scroll along the timeline below the video. So I hope you find these solutions are useful in your journey towards success in your GCSE exam. Well, here we have question 1. And in part A, we're asked to write 0.27 as a fraction. 0.27 as a fraction. Now, two ways you can do this. You either get your calculator and use that, or it looks straightforward here if you realise that this is the hundredths column and we've got 27 hundredths. So you can read that fraction straight away from this decimal. 0.27, 27 hundredths. If you're wanting to use your calculator, now some calculators have a fraction mode, and look, there's a decimal mode that I'm in. If I click that, it changes to a fraction mode. Now you can only use this if you know your calculator does have a fraction mode like this. And so what I'm going to do now that I'm in fraction mode is I'm going to enter 0.27, and when I now press the equals, there's my 27 hundredths being the same as 0.27, just as we had before. So that's part A. Let's move on now to part B. Better write the answer. So 27 hundredths. Now part B, write 2/5 as a decimal. Again, you could enter this in your calculator and just work that out. However, there is a nice way of doing this. If we double the numerator and denominator, 4/10. And as a decimal, that would be 0.4. There's the tenths column, 4/10. So as I said, it's that way, or we can just enter 2 divided by 5. Now, I'm in fraction mode. I'd better put that back to decimal mode. So 2 divided by 5, and that equals 0.4, as we stated. Now, I do have another way of entering a fraction like this. You may have a button like this. If I press that button, up pops 2 little boxes. Now I'm ready now to enter the 2 in the top line if I press 2, but I have to move that cursor down to the bottom of the fraction. I would use this arrow to do that. You can see it's now down at the bottom, and I would enter a 5. And now I should press the equals, and there 2/5 exactly the same as 0.4 as before. So let's look at part C now, final part in this question, and we're asked to write 0.35 as a percentage. Now 0.35, just like we did up here and wrote this as 27 hundredths, this would be 35 hundredths. So 35 out of 100 is exactly what 35% is. You can almost see that line and the 100 jumbled up in this percentage sign, out of 100. So 35 hundredths is 35%. There is another way of doing that, where if you're given any number and you want to change it to a percentage, you multiply it by 100%. Now 100% is just another way of writing 1. And if you multiply 0.35 by 1, you're still getting 0.35. So you're not altering anything by multiplying by 100%. And what is 0.35 times 100? .35 times 100 gives us 35. With a percentage sign. So the answer 35 with that percentage sign. 0.4 was the answer to part B. Forgot to put that in. So there's the 3 parts of question 1. So here we have question 2. And in part A, we're asked to simplify fully x plus 4x. Well, there's 1x. This bit tells us there's 4 lots of x. 1, 2, 3, 4. And we're asked to add these all together. That'll surely give us 5 lots of x. So there's part A. Let's move on now to part B. And it says simplify fully 5 times 2w. It's like 5 lots of 2w. 1, 2, 3, 4, 5. 2, 4, 6, 8, 10 w's. We're just multiplying the 5 and the 2 together. It's 10 lots of w. Part C. Simplify fully 2m divided by m. Now how we normally write that without the divide sign is 2m over m. It's like having 2 times 6 over 6. And what you do is divide top and bottom by 6 to get 2. If it was 2 times 3 divided by 3, that's 6 divided by 3. Cancel the 3's and you're left with 2. Cancel these m's and you're left with 2. And finally for this question, simplify fully y times y times y. Now things like 3 times 3, remember you can write that as 3 to the power 2 or 3 squared, and 3 times 3 times 3, that's 3 3's multiplied together. 4 lots of 3 multiplied together. The little number up here, the index, the power, tells you how many of these things to multiply together. So in this case, we're taking 3 lots of y and multiplying them together, so we'd have a little 3 up there. It's y cubed, or y to the power 3. 3 lots of y multiplied together. So here we have question 3, and we're shown a picture of a quadrilateral. All the angles are labelled A, B, C and D. And in part A of the question, we're asked to write down the letter of the obtuse angle up here. Now, before we choose one, let's remind ourselves what obtuse angle is. So here we have a diagram showing a right angle. There's a right angle. There's the 2 arms that make up that right angle. Now, any angle that's less than a right angle, and all these angles I'm showing you now are less than a right angle, they're all acute angles. So there's a right angle again. Angles larger than a right angle all the way up to a straight angle 180 degrees are called obtuse. So all these are obtuse angles, and we go all the way up to 180 degrees, that's a straight angle. So anything less than a straight angle but bigger than a right angle is obtuse, and anything smaller than a right angle will be acute. So in part A of this question, we're asked to write down the letter of the obtuse angle. There it is there. So that's C. And let's go to part B in the question. It now says write down the letter of an acute angle. Well, that's acute. It's less than 90. And this one's acute. It's less than 90. There's a 90 degree right angle up there. So either A or D. Let's move on to part C. And in this one we're asked how many lines of symmetry does this shape have. Well, let's remind ourselves what a line of symmetry is all about. So here's a sheet of paper. I'm going to fold this sheet of paper across so that we've got a vertical fold. There's an axis of symmetry. The two halves are identical. We could put a mirror down there and one half would be reflected and fit exactly on the other half. That's one axis of symmetry. There is another way of doing this. We could fold the sheet of paper down the way so that the top half fits on the bottom half. There's another axis of symmetry. A mirror could go along there. Both halves would fit onto each other. So that rectangle has two axes of symmetry. So, is it possible to fold this shape so that the two halves fit on top of each other? Is there somewhere we could put a mirror so that the two halves that we're seeing look identical? Well, let's try it. So here's the original shape, the angles A, B, C, D, and I've copied it down so that there it is in red, and I've got a mirror. Now, just to show it's a mirror, you can see there's the reflection of the red shape. So, can we place that mirror along a line so that when we fold the shape over that line it fits exactly onto itself? Well, look, here's a possibility, but you can see it's not quite right. It's not fitting on top of itself. So that's not a line of symmetry. And we can move this around. Let's see if we can find a line of symmetry for this shape. Is there some place that we can fold it over and the two halves fit exactly on top of each other? You know, I'm going to be here all day trying this. I just don't think that's possible. There appears to be no lines of symmetry. None. So the answer to our question, how many lines of symmetry does this shape have? We would write none. Okay, so here's question 4a. And we're told that one lettuce costs £1.29. And we're asked how much 7 lettuces cost. So it's a times 7 problem. So let's get the calculator onto this. So let's put in £1.29 and we'll multiply it by 7. And there we go, £9.03. £9 3 pence. Let's look at part B. Now we're told in part B that 5 cucumbers cost £6.40. And we're asked to find the cost of 2 of them. So first of all, let's find the cost of 1. And what we'd have to do is divide. How many times does 5 go into £6.40? So there's a divide by 5 going on. So let's attempt that. So £6.40 divided by 5. And there we go. It's £1.28. £1.28. Now it was the cost of 2 we were after. So if we know one of them costs £1.28, then 2 of them is going to cost twice that. So we take this £1.28. Now I press my ANS key here, and that'll bring this number up into being active. There we go. And I'll multiply it by 2. And that equals £2.56. £2.56. Here's question 5. We're told that a company sells 3 types of bottles. There's plastic, there's glass, and there's steel. And this diagram represents the sales they've made during the course of 1 week. Now, to understand this diagram, you have to look at the key. And the key says that a wee block of 4 rectangles like that represents 20 bottles. And it's worth thinking that if that 4 rectangles represents 20 bottles, then each one must be a quarter of 20. That'll be 5. 5, 10, 15, 20. So there's the amount of plastic bottles sold in the week, there's the amount of glass bottles sold in the week, and here's the amount of steel bottles sold in the week. And there's a single rectangle there. So we're going to have to use the fact that each little rectangle stands for 5 bottles. So in part A, the company sold more plastic bottles than glass bottles that week. How many more? Well, if we look at the diagram, there's the plastic bottles represented and there's the glass bottles, and you can see that this lot is the amount more. And how do we work that out? Well, it's 3 lots of 20. And that would be 60. So the answer is 60 more bottles. There is another way to do it. You could work out the plastic bottles in total, 1, 2, 3, 4, 5 lots of 20. So the plastic bottles would be 5 lots of 20, and that's 100. Remember, you do have your calculator, so you could work these out on your calculator. How many glass bottles? 1, 2, 2 lots of 20. So glass, 2 lots of 20. Well, that would be 40. So the amount more that we're after would be 100 minus 40. And again, that'll give you your 60. Now, part B. Company sells each steel bottle, there's the steel bottles, that represents the steel bottles, for £17.50. Work out the total amount of money made from selling steel bottles. So how many steel bottles did they sell that week? So the number of steel bottles, well, let's have a wee look. It's 1, 2, 3, 4, 5, 6 lots of 20. And then we've got this little rectangle. Remember we said that each one of these rectangles, 5, 10, 15, 20, each one represents 5. So you can work this out in your calculator. 6 20s, 120, plus 5 is 125. So total amount of money made, the money made, how would we do that? Each one is sold for £17.50. So it's £17.50 times 125, 125 lots of £17.50. So that definitely needs the calculator to be brought in. So £17.50 multiplied by 125. And there we have the answer. It's £2,187. Now that 0.5 is not 5 pence, that would be 0.05. So this is 50 pence, not 5 pence. So there's your final answer, £2,187.50. Let's write that in. So that's question 5B. So here we have question 6, where we're shown this shape, A, B, C, D, E, and we're asked to complete this statement in part A. Now we've got 2B dots in here, and you'll remember that 2 dots means that you're dealing with a ratio. So the ratio on the right hand side here of the equal sign, 5 to 1. The statement involves lengths of lines, AB, that's this line up here. Let me indicate that. There's AB, that would correspond to the 5. So what we're looking for is a line in this diagram that corresponds to length 1. We've got AB corresponding to 5. So the missing line would have to have length 1, and we're required to put the name of that line in. Well, there's the line of length 1. DE is not of length 1, it's slightly bigger than length 1. So the line we're after is DC or CD. So let's write that in. And just to complete the colour scheme, there we are. So length AB to length DC is length 5 to 1. AB is 5, DC is 1. So that's that statement completed. So let's move on to part B. And in this part, we're asked to draw a rectangle with the same area as this shape. So our first task is to work out what the area of this shape is. So let's look at a larger picture of that, and let's try and figure that out. So talking about whole squares, these are whole squares, and there's 4, 5, 6, 7, there's 8 of them. These are half squares, and there's 4 of them. So the area of this would be 8 whole squares plus 4 half squares. Now we know that these 4 half squares, 2 halves would be 1, another 2 halves would be 1, so 4 lots of a half, that's 2, a half of 4 is 2. 2 half squares make up 1 whole square, so there's 8 plus 2, there's 10 squares altogether. So that's the area of this shape by counting squares. So we need to have the rectangle having an area of 10, and we know that a rectangle has an area of length times breadth. So we're looking really for 2 numbers multiplied together that give us an answer of 10. 5 times 2. 10 times 1. Either of these would do. Let's take 5 times 2. So a length of 5 1, 2, 3, 4, 5. There we go. And of course the opposite side would have the same length. Now, the breadth of 2 so that would be a perfectly adequate answer. And of course the other one is 10 along. So we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that would be the same as the opposite side. And then breadths of 1. So there we go. There's a 5 by 2, which is 10, or there's a 1, a 10 by 1, if you like. So 5 by 2 or 10 by 1. Either of these shapes would work. So here's question 7. And we're told that we have to use a ruler. This is an accurate drawing of an equilateral triangle. Now remember, equilateral means all sides are the same length. By measuring, we have to work out the perimeter of the triangle. That's the total length all the way around the triangle. That's 3 equal sides we'd have to add together. And we have to state the units of our answer. Well, here's the triangle, the exact size that's in your question paper. So let's bring on the ruler and see what we can do with that. So here's the ruler, and I'm going to line it up with this diagonal side. Now, one of the mistakes people make is to put the end of the ruler at the end of the line. You don't do that. You put the first of these marks against the end of the line and do it accurately. Now we can go down and have a look at the end of this edge. This is measured in centimetres. There's 1, 2, 3, 4, 5, 6. That line, the big line there, is 7 centimetres. The smaller line is 7.5. Now, by the looks of it, that's 1 mark before 7.5. That would be 7.4. So the length of one of these edges is 7.4 centimetres, or 74 millimetres. I'll use centimetres, 7.4 centimetres. Let's write down one side equals 7.4 centimetres. 3 sides, and you can get your calculator for this, would be 3 times 7.4 centimetres. And that, from your calculator, will turn out to be 22.2 centimetres. Now that centimetre there is important. If you were working in millimetres, it would be 222 millimetres. And you would be saying this is 74 millimetres. This line would be 3 lots of 74 millimetres, and you'd get your calculator to work out 3 times 74, you'd get 222 millimetres. Well, here's question 8, and we're told there's 56 cubes in a box. So somewhere we have a box containing inside it 56 cubes. The cubes are green, red, blue, or white. So there's green, there's red, there's blue, and there's white. 17 cubes are green. And there's an equal number of red, blue, and white cubes. So these numbers are identical. And it asks us in part A how many red cubes are in the box. Well, first of all then, let's work out how many of these 56 cubes are not green. So that would involve 56 minus 17. Now you should have your calculator handy and you can do these. That would give us 39 cubes. Now remember, we said each of these numbers is the same. So to find what these numbers are, we need to take a third of 39. We divide 39 by 3. And again, use your calculator if you need to. We get 13. So there's 13 reds, 13 blues, and 13 whites. Now, you'd maybe be wise at this point to check that 17, add 13, add 13, add 13 does indeed come to 56. That's easily done in your calculator. So things are going okay. So we know precisely what's in there. We were asked how many red cubes are in the box. Answer, there are 13 red cubes. And there's your working that shows you knew what you were doing. So let's move on to part B. 24 more cubes are added to the box. Okay, well let's deal with that. Let's take the box, which originally had 56, and we've now got to add 24. So we're now going to have 80 cubes in this box. And we know that the green ones are still going to be 17. Red ones is going to be 13. Blue ones still going to be these 13. And white ones, there's still going to be these 13. However, we've added 24, so there's now unknown cubes, and there's 24 of them. So there's all that we know about these 80 cubes. 17 green, 13 red, 13 blue, 13 white, 24 of them we have no idea yet what colour they are. Now, we're told that if we pick a cube at random out of this, then the probability that that cube is green is 0.4. So the probability of a green cube coming out of that box is 0.4. That's 4/10. Now, we can therefore, because we know there's 80 cubes in there, we can work out how many green ones are in there. If we work out 4/10, 0.4 times 80, again, get your calculator onto this, you end up with 32 green cubes. So there's a fact. We've got 17 known green ones in there. We've now got total of 32 green cubes. So we used to have 17. We've now got 32. Number of greens added. How would we do that? We had 17. We've now got 32. Well, we'd take 17 away from 32. And that would give us 15. 15 added on to 17 gives us the 32 total that we now know are in there that are green. So the answer to that was 15 cubes have now been added. Green ones, that is. And they'll expect to see some of these that expect to see this 80 total, that expect to see this 4/10 of 80, 32, and they'd expect to see the 32 minus the 17 to get you 15. So that's the working that you should show. Okay, so here's question 9. And we're told that an electric car uses 1 unit of electricity to travel 3 miles. So we have 3 miles, and that corresponds to 1 unit. So that's that information. We're told 1 unit costs 50p. We have to work out the cost of electricity in pounds to travel 270 miles. Now there's 2 ways of setting this out. You could figure out that to get from 3 miles to 270 miles, we'd have to multiply by, well, how many 3's go into 270? You'd use that on your calculator. 270 divided by 3, you'd find it was 90. Now, so what we've got, 3 times 90 gives us this 270 miles. So to find out the number of units used in travelling 270 miles, we'd have to multiply this 1 unit by 90. You're going 90 times the distance, so you'll use 90 times the units. In other words, you'll use 90 units. Another way of setting it out, 3 miles, you use 1 unit. If you went just 1 mile, that would be 1/3 of the distance. So you'd only be using 1/3 of a unit. So if you know how many units you're using per mile for 1 mile, and you're trying to work out 270 miles, you just multiply by 270. So you've got 1/3 of 270. And on your calculator, divide 270 by 3, you'll get 90 units. So either way would be fine. So what's the cost? Well, we know 1 unit costs 50 pence, so 90 units will be 90 lots of 50 pence. Now on your calculator, when you go 90 times 50, you'll end up with 4,500, and that's pence. Now you are asked to put your answer into pounds, so it would be 45 pounds. There's 45 hundreds. There's 100 pence in a pound. 4,500 pences, 45 pounds. So there's your answer, 45, and you're working. Well, here's question 10A. And we've got Lima buying 2 metres of linen at £8.50 a metre. So there's 1 metre, and there's another metre, 2 metres of linen. Each one of these costs £8.50. And she also buys 5 metres of cotton. So there's 1, 2, 3, 4, 5 metres of cotton. So the total cost, all of these together, will be £38. And it says, what is the cost of 1 metre of cotton? That's the cotton, and this is the linen. So what we can say is that the cost of the linen costs 2 lots of £8.50. Get your calculator to do that. That's £17. So that must mean that the cotton costs, well, total cost is £38, so it must be £38 minus the cost of that linen. So we have to take 17 from 38, and you can do that in your calculator. You'll get £21. So £17 on the linen, 21 on the cotton. You can just check that 17 plus 21 does give you 38, so everything's working so far. So £21, she buys 5 metres of cotton. So each one of these must cost 1/5 of £21. We divide £21 by 5. So 1 metre of cotton costs, and somewhere you'd write down that you knew what you were doing, 21 divided by 5. So we can bring on the calculator to do that. There we go. And we'd put in 21, and divide that by 5 to see what happens. And there it is, 4.2. So I'll write that down, 4.2. Now that is not £4 and 2 pence, that would be 4.02. So that means it's £4.20. So 1 metre of cotton costs £4.20. So let's write that down, £4.20. There's the pound sign. Something like this should go into your working so that they can see all the bits and pieces that you've done. This subtraction to get the 21, this division to get 1 metre of cotton, and your final answer, of course, £4.20. So let's move on to part B of the question, and this time we're talking about buttons that cost 65 pence each. And the greatest number of buttons that Lima can buy for £5 is 7. And she says the greatest number of buttons I therefore can buy for £10 is 14, because if you double 5, you get 10. And if you double the 7, I'll get the 14. Is she correct? And we have to do some working out for that. So let's think about 7 buttons. 7 buttons cost 7 lots of 65 pence. So let's find out exactly what the cost is of these buttons. So we'll put in 7 times 65. And look, that gives us 455. That's £4.55. So certainly she cannot afford more than 7 buttons with her £5. Because 65 pence, she's only got 45 pence left. So let's work out now 14 buttons and see if she's correct in what she says. So 14 buttons cost, now either you work out 14 lots of 65 pence, or because it's double the amount, you could double the £4.55. Let's just do the 14. So it's 14 times 65 this time. And that comes to £9.10. £9.10. Now that's interesting because she has £10. How much does that leave her? That leaves her a whole 90 pence. You've got £9.10. She's got £10. She would get 90 pence change for buying 14 buttons. However, a button costs 65 pence. So she can afford 1 more at 65p. That would actually leave her 25p. So she's wrong. She can buy 15 buttons. For all the reasons that I've got there. So you'd put the £9.10 down, and you'd put the 90 pence down, and say that she could buy 15 buttons. That would be enough to get you your marks. Well, here's question 11. and we're given a table of values for this equation. Y is 3 times x plus 1. And you can see the values of x go from 1 to 2 to 3 to 4. Let's check this. Multiply the x number by 3 and add 1. 3 ones are 3 plus 1, 4. 3 twos are 6 plus 1 is 7. 3 threes are 9 plus 1 is 10. 3 fours are 12 plus 1 is 13. Now we have to draw the graph of this equation for values of x from 1 to 4. So here's a larger diagram, and let's start with x being 1 and y being 4. That gives us a point on the graph. X is 1, we go 1 along and 4 up. So there's a point on the graph of that equation. Let's do the next pair of values. X is 2, y is 7. So we go 2 along. Now the problem is there isn't a 7 there. But between 6 and 8 there's 1, 2, 3, 4, 5 squares. So halfway would be 2.5 squares. So we can be as accurate as putting the point on the vertical line through 2.5 squares above the 6. So there's the second point on the graph of that equation. And let's continue. 3, 10. We go 3 along the x and 10 up parallel to the y. So there's a third point on the graph. Finally, 4, 13. 4 along the x, 13 up parallel to the y-axis. And we have the same problem. 13 would be 2.5 squares above the 12 line. So there's the points. Let's get the ruler onto this and we'll try and be as accurate as we can with this. Oh, I think that's pretty good. Let's draw a line. Now it's from x being 1 up to 4, so let's not go beyond that. It tells us only to do this from x being 1 up to x equals 4. So we'll stop off at the 1 and stop off at x equals 4. So there's the graph that they're after. So that's 4 points we've used, and they're all lying on the graph of that equation. So let's have a look now at 11b. It says work out the value of y when x equals 2.5. Well, this formula tells us how to do that. It tells us to take the x coordinate, multiply it by 3, and then add 1. So that's one way of doing it. And 3 lots of 2.5 be 7.5 plus 1 would be 8.5. So y would be precisely 8.5. Of course, the other way you can do that is to go to the graph and look at x being 2.5. Now that's halfway, or 2.5 squares to the right of 2. You would then look at a vertical line going up to the graph and read the value of on the y-axis, but that is not as accurate as the method we've just used of using the formula. I would recommend you just to use the formula. Well, here's question 12. And we have to try and build a code up, or discover a code that has 5 different digits, written in order, starting with the smallest. The last digit is the only square number, the middle digit is the only even number. and we have to discover the code. So let's think about what digits are. Digits, there's 10 of them. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the 10 digits that we use to make up our normal numbers. So which ones are square numbers? Well, 0 times 0. Remember, a square number is a number times itself. 0 is a square number. 1 times 1, that's a square number. 4, 2 times 2, that's a square number. 9, 3 times 3. So 0 times 0, 1 times 1, 2 times 2, 3 times 3. There's 4 square numbers there. Even numbers, ones that 2 goes into exactly. 2 goes into 0 no times. 2 into 2 goes once exactly. So 2, 4, 6 and 8. You maybe normally don't think of 0 as an even number or a square number, but it certainly is. So there we go, and the ones that are left that aren't squares or even numbers are this 3 and this 5 and this 7. So let's have a look at the code, see if we can figure out what this code is. So there's 1, 2, 3, 4, 5. 5 digits. And what do we know about them? They have to be increasing from left to right. They're in order. Last digit, that's the 5th digit, that's this one, is a square. Middle digit, that's this one, is the only even digit. And that's all we're told. So we'll start looking maybe at the last digit, because we've got very few square numbers, 0, 1, 4 and 9. And let's start out with 0. I'm sure you can see why we cannot have 0 there, because we can't have any numbers in here because the numbers are all increasing. Likewise, we couldn't have a 1 there. We could possibly have a 4 there, but that would mean we'd have to have 0, 1, 2 and 3. What's wrong with that? Well, there's more than one even number. And the middle one is the only possible even number. So that's not going to happen. So that doesn't leave us many squares. It only leaves us the 9 as the last digit. Now let's see what we can do with the middle digit being even. And the only even ones we've got are 0, 2, 4, 6 and 8. And you can maybe see why we would rule out 8 in the middle, because there'd be nothing to go in to there, into the second last digit. Remember, they're increasing. So we can't have 8. We couldn't have 0 for the reason that there's nothing to put in there that's smaller than 0. We can't have 2 in the middle because 0 and 1, there would be another even number there, and 2's the only one. So we can't have 2. And can you see why we can't have 4 in the middle? Well, remember, 4 was a square number. 9, the last digit, is the only square. So we cannot have 4 in the middle. That would involve two square numbers, not allowed. So that only leaves us a 6 to go in the middle. Now, the only even number it said was the middle digit. That's the only even number. So we're left with odd numbers. Now the odd numbers we're left with is 1, 3, 5, 7. We certainly can't use 1 because that's a square number. We're only allowed the 9 as a square number. Doesn't leave us much choice. There's only 3, 5 and 7 left. So there's our code. 3, 5, 6, 7, 9. Now really when you reach this stage you should check everything's correct again. It's got 5 different digits. Are they written in order? 3, 5, 6, 7, 9? Yes, they are, starting with the smallest. The last digit's the only square number, 3 3s, that's 9. None of these are square numbers. The middle digit is the only even number, 6. All the other numbers are odd. That's it. So here's question 13. We have 4 numbers and we're told they have a mean of 10. But they're being mean with their information. They're only telling us 3 numbers. So how do we work out a mean? Well, remember what we do. We add up the numbers and then we divide that by the number of numbers. So in this case we've got to add up 5 and 8 and 9 and we don't know what. Let's call it x. And we divide that by, well, how many numbers are we adding up? We know 3 of them, but we have a 4th one which is unknown just now, so there's actually 4 numbers. And that's going to give us an answer of 10, they say. The mean is 10. It looks like we're getting a little equation built up here. So you have calculators, so you can do this in your calculator, but 5 plus 8 plus 9, that's 22. And we've still to add this unknown number. Now, whatever the number is in the top of this, when we divide it by 4, we're going to get 10. So this number is going to be 40. If you're thinking like an equation, how do you get rid of divide by 4? You multiply by 4 and that'll vanish. But you have to balance it and multiply the right hand side by 4. So whichever way you're thinking about it, that number is 40. 40 divided by 4 is 10. So 22 plus something is 40. Again, if you're thinking equations, get rid of this by subtracting 22 from both sides. 40 minus 22 is 18. Again, use your calculator for that. So that seems to be the answer. Now, if you're wise, you would maybe check that. How do you check it? Well, we know all the 4 numbers, supposedly. The 4th one's supposed to be 18. Well, what do we get when we add up all of these? Well, you check on your calculator, they come to 40. And if you divide 40 by 4, you certainly get 10. So that ties in with the mean being 10 of these 4 numbers. So your answer, 18. So here we have question 14. And in part A, we're asked to rearrange this formula to make h the subject. Now, the subject of a formula is the single letter that appears at the front on the left of the equal sign. There's usually a single letter there. You know, some formula like the area of a circle is pi r squared. The A is all on its own. The circumference of a circle is pi times the diameter. That subject is C, that subject is A, this subject is D. We're trying to make H the subject. We want H on its own. Now, think of this as an equation. There's the equal sign. What is on the left of the equal sign and what is on the right of the equal sign? They're two balanced things. They're equal to each other. So whatever we do to one side, we must do the same to the other side to keep that balance. Now, if I'm wanting to get H all on its own, I'm looking at this take away 4 and I'm thinking, okay, what's the opposite of taking away 4? Well, that's adding 4. So I must now do that same thing to the left-hand side of that equation, always doing the same to each side to keep it balanced. So what have I got on the left-hand side? Well, I've got a D, and now I'm adding 4 to it. And what have I got on the right-hand side? Well, the reason I'm adding 4 is to destroy this take away 4. So they just vanish, and I'm left with H. And we now have H on its own, but we don't normally write formula, for instance, the area of a circle formula. We never write it that way round. We normally put the letter on the left-hand side. So we'd have to turn this round the other way. H is equal to D plus 4. H equals D plus 4. So there's our rearrangement. H is equal to D plus 4. And that is now the subject of the formula being H. So let's move on to part B. It's another rearrangement. This time the formula has subject P. We're told you'll find P by taking W and dividing it by 3. So this time we're attempting to get W on its own. So how do we get W on its own? We'd get rid of this divide by 3. Now, what's the opposite of dividing by 3? That's multiplying by 3. If we do that on the right, we must do that on the left. Otherwise, the whole thing won't be balanced. So what have we now got on the left-hand side? We've got P times 3. 3 lots of P. 3 times P. That's how we write it. And on the right, why are we multiplying this by 3? We're trying to get rid of this divide by 3. So these two things vanish and we're just left with W on its own. Doesn't look the right way round. W is equal to 3P. W is equal to 3P. So there's the formula with W being the subject of the formula. We've changed the subject from P to W. Here's question 15. We're told that a linear sequence begins 2, 5, 8, 11, and we have to work out an expression for the nth term. So let's write these numbers down. 2, 5, 8, 11. It's linear. What that means is we're adding on the same amount each time. We'd be adding 3 to get from one term to the next term. We'll check that. 5 plus another 3 does give you 8. And 8 plus another 3 does give us 11. And that procedure goes on and on and on. So this is the first term. This is the second term. This is the third term. And this is the fourth term. We're trying to get along to the nth term and find out what on earth we do. Now, the clue is in this plus 3. And for the nth term formula, think multiplying with 3. Take the number of the term that you're at and multiply it by 3. Let's try that. 3 times 1 is 3. Oh, we need to take 1 away. 3 times 2, that's 6. Oh, we need to take 1 away. 3 times 3 is 9. Oh, we need to take 1 away. 3 times 4, that's 12. Oh, take 1 away again. 3 times n. Oh, we'll need to take 1 away. We've just developed an expression for the nth term. The nth term, you multiply the number that the term is, the 1, the 2, the 3, the 4, by 3, and then take 1 away. This is 3 1s, take away 1. This is 3 2s, take away 1. 3 3s, take away 1. 3 4s, take away 1. If you want the 100th term, it would be 3 hundredths minus 1, 299, and so on. So the answer, write out an expression for the nth term. That expression is 3n minus 1. That's your expression for the nth term. So here's question 16. And this diagram shows a circle. It's got a centre O, and there's 3 straight lines with a couple of shaded areas. And we have to use one word to describe each of these shaded areas. And we've got a selection of words that we can choose from: arc, chord, sector, segment, tangent. Now, look inside your memory. Somewhere in there you should have these. If you don't have these, the meanings of these words, then learn them. Let's look through this. Radius, centre out to the edge of the circle, the circumference of the circle. From the centre out to the circumference, that's your radius. Diameter goes right through the centre from one point on the circumference to the diametrically opposite point on the circle. Circumference all the way around the circle. A chord, 2 points on the circumference joined up. That's what the diameter is. So the diameter is a special chord. Chords in general don't need to pass through the centre. 2 points on the circumference, join them up. That's a chord. Now the arc is part of the circumference of a circle. Tangent's a line which just touches the circle at one point. It's like a wheel rolling on a road surface. It just touches at one point. That's a tangent to a circle. Here's a chord. The area between that chord and this arc of the circle is called a segment. There's 2 radii and an arc. The area in between that is called a sector. Now these two are easily confused, a segment and a sector. Segment, chord and arc, sector, 2 radii and an arc. So let's look at the picture we've got. Well, that sector is there. That segment is there. So A, region A, is a segment because it's contained by a chord and an arc. Region B is a sector because it's contained by 2 radii and an arc. Now here's question 17, and we've got a couple of vectors that we're adding together. 1, 2 and 4, 6. And the way to do this is to add the corresponding components, the 1 and the 4, the 2 and the 6. But before we go ahead and do that, well, let's just see why that works. The vector 1, 2, let's represent that by going from here, 1 along, 2 up. So the x component is 1 and the y component is 2. So that involves a little journey, 1 along and 2 up. Now this second vector, 4 along, 1, 2, 3, 4, that's the x component, 6 up, 1, 2, 3, 4, 5, 6. So we do the 1 along, 2 up journey, followed by 4 along and 6 up journey. I'll get the ruler out to do this one. There we go. So the reason we can add the two x components is because if we're going 1 to the right, followed by 4 to the right, then we've gone 5 to the right. That's the x component of the single journey that would go from the start to the finish of this. X component is 5 units. 2 plus 6, that's the heights. Going from there to there, you've gone up 2, followed by up another 6. So altogether, to get from there to the end point, you've gone up 8. So we're going along 5, followed by 8 up. So you're basically just adding the two x components, adding the two y components to get our answer. So here's question 18. We're told we have two bags containing counters. In bag A we've got red and blue. In bag B we've got white and green. Bag A, we're told that 1/4 are red, the rest are blue. Well, that would mean 3/4 of them are blue. 3/4 and 1/4 make up the whole bag of counters. One bag. 1/4 plus 3/4 is 4/4. That's 1. So on this diagram, we have to complete it. Here's bag A here, which we now know has 1/4. That's the fraction of the counters that are red, and 3/4 of them are blue. So if we start off here and we're wanting a red one, there's a probability of 1/4 that we'll get a red one. If we're wanting a blue one out the first bag, the probability's 3/4, 3 chances out of 4 to get a blue counter. Now let's look at bag B. What do we know about bag B? There's 3 white and 2 green. In other words, there are 5 counters. So, white counters, what fraction of the counters are white? 3 out of 5. So that's 3/5 white. And what fraction of the counters are green? That's 2 counters out of the 5. So that's 2/5 green. And you can check again, 2/5 plus 3/5 give you 5/5. That's 1. That's one whole bag. That's bag B. So let's complete this. We can start with bag A, choose a red counter, and then what are the chances of a white counter? Well, the probability there is 3/5, 3 chances out of 5. And what are the chances of a green counter? Well, that's 2/5, 2 chances out of 5. And similarly, if we'd chosen a blue counter out of bag A, we could then choose a white counter, which would be 3 chances out of 5, 3/5, and a green one, 2 chances out of 5. So that would be the completed tree diagram. Let's move on now to part B. And we're asked in part B, or we're told in part B, that one counter is taken at random from each bag. Work out the probability that one is red and one is white. Now, one being red, and one being white, that's the path that we've travelled. So, what are the probability of going into bag A and getting a red counter? Probability of red is 1/4, followed by the probability of a white one, which is 3/5. And to get the resulting probability, red and white, we would multiply these two probabilities together. They're completely independent of each other. One of them doesn't depend on the other. So it's a straightforward multiplication. So we'd have 1/4 times 3/5, which would give us, now multiplying these, 1 times 3, 4 times 5, be 20. So our answer would be 3/20 for that probability. Now, you could have worked in terms of decimals. This would be 0.25. This would be 0.6. You can work that out in your calculators. And 0.25 times 0.6, you'd end up with 0.15. So that would have been acceptable. But in that case, you would have had these being replaced. There's a 0.75 by decimals all the way. That's 0.6, 0.4, 0.6, 0.4. So working in terms of decimals would be perfectly acceptable. So here's question 19. And we're shown a right angle triangle, and we have to use trigonometry to work out the value of x. Now, trigonometry would involve sine, cosine, tan, and you do get in your exam a formula sheet, and this is the relevant part, not this bit, but this bit down here, where there's a right angle triangle, and we're told that the sine of this angle A is A over C. That's this opposite side divided by the hypotenuse. So the sine is the opposite divided by the hypotenuse. And the cosine is the adjacent, that's right next to the adjacent side over the hypotenuse, B over C. So the cosine is the adjacent over the hypotenuse. And the tan of A, that's opposite over adjacent. Tan is opposite over adjacent. Now, there's a word when you read it that says SOHCAHTOA. You might well have been taught that the sine, cosine and tangent, you can remember which side to divide by which, by using SOHCAHTOA. But you do get this on your formula sheet. So let's look at this triangle. There's the 24 degrees. The opposite side is x, which is what we're trying to find, and the hypotenuse is 31. So we're involving the opposite and the hypotenuse. Opposite and hypotenuse. That would involve sine. If you're using your formula sheet, there's A over C. That would involve the sine. So we can use that, and we can write down the sine of 24 degrees is the opposite, which is x, and divide that by the hypotenuse, which is 31. So the question is asking us to work out the value of x, and we have a little equation here. Let's try and get x on its own. So as usual, we do the same to both sides. So we want to get rid of this divide by 31. So the opposite of dividing by 31 is multiplying by 31. And if you've multiplied the right hand side by 31, you must do that to the left hand side so that both of these sides are balanced still. So 31 times sine 24, we'd write that as 31 lots of sine 24 is equal to, well, why did we multiply by 31? Well, to get rid of that divide by 31. So we'll just be left with x. So here's a little recipe. Let's turn it round the other way. To find x, it says you take 31 and multiply it by whatever sine 24 is. And that should give us our answer. Now, to do this calculation, we're going to have to bring on the calculator. Here it is. Now, make sure in your calculator that DEG is showing on your calculator. If I press that on my calculator, look, it changes to rad, and you do not want rad anywhere on your calculator. It would show up on the display somewhere. And you also do not want GRA showing. You must have your calculator talking degrees to you. That's what this means. This means the calculator is thinking in terms of degrees. So let's go and put this lot in. So we do 31 multiplied by, and then the sine button, there it is. When I do sine in my calculator, I've got a bracket appearing. It's 24 degrees, and we do know the calculator is now speaking degrees. I close that bracket and press the equal sign. And there is the answer that I get. So it's 12.60 and so on. So that would be our answer. That's approximately, I'm going to round that off to 1 decimal place. So it's 12.6. And it's in centimetres because that hypotenuse was measured in centimetres. Well, here's question 20. And we're told that the mass of an iceberg is 2,200,000 kilograms. And we're told that this is a 12% reduction from the original mass. Iceberg melts over time. They're wanting us to work out the original mass of that iceberg. So a 12% reduction, let's say that the original mass, that'll be 100% of the iceberg. And it's been reduced by 12%. So what percentage is now left? Well, we would take 12 from 100, and we'll get 88. So 88% is left. So there's what we've got to go with. 88% of the original is 2,200,000 kilograms. So how do we get 100% if we're sitting looking at 88%? Well, one of the ways is to figure out how to get 1%. And if we know 88%, 1% will be dividing by 88. So we would take this figure and divide it by 88. And we've got calculators, we'll do that in a wee minute. Now that's only 1% of the original iceberg. Well, at least that's progress, because now how do we get to 100% if we know what 1% is? Well, we would multiply by 100. Take this number, whatever it is, and multiply it by 100. And we've now got the wee recipe that will give us our answer. So we now need to bring on the calculator. And here we have it. So let's do that calculation. So that's 2,200,000. We divide that by 88 and then multiply by 100. And there we go. So the answer to that part of it is 2,500,000 kilograms. However, the question says give your answer in standard form. So on my calculator I have a button ENG, and if I press that, my calculator now goes into a different mode where it can take this number. So I'll take that answer that I just got and then press equals. It changes that number to standard form. That's a piece of magic that my calculator does. Your calculator also can do that. So find out how your calculator changes numbers to standard form. There is another way of doing it. If we take a number like this, understanding how this works, you would, the decimal points at the end there, this is the millionth column, but we're wanting to get a number between 1 and 10. That's important by moving this point along the number, and to do that we would have to move it between the 2 and the 5. And basically what this times 10 to the power does, this number 6 tells you how many places to move that decimal point back, 1, 2, 3, 4, 5, to get to where it was. So that's really 10 to the power 6, 6 tens multiplied together, that gives you 1,000,000. If you're multiplying 2.5 by 1,000,000, you get 2,500,000. But this is now called standard form. So what is standard form? A number between 1 and 10 and the instructions for getting that point back to where it was at the end. 6 places to the right. There it is. Move it 6 places to the right. But it's much easier if you know how your calculator can turn a number into standard form. And then there'll be no doubt that you've done the thing correctly. Oh, here we've got a chef with a tub of blueberries. What's she going to do with these? She's going to make desserts. She's going to use all the blueberries in the tub and she's going to put the same number of blueberries in each dessert. Now, we're given this formula where the number of desserts is big D, capital D, and this is the number of blueberries in each dessert. And that, remember, is the same number in each dessert. And the question asks us, first of all, what on earth does that stand for? Well, let's do a simple example. Suppose we've got 6 desserts that she's making up. Remember, she's got this big tub of blueberries. And suppose she wants to put 2 blueberries in each dessert. Now, here's a bowl. Here's another bowl. So these are the 6 desserts that she's making up. So we've got a picture of 6 bowls. And she plops 2 blueberries in each bowl. Now, we know that you'll get 6 by dividing 12 by 2. So what on earth does that 12 stand for? Well, there's 2, 4, 6, 8, 10, 12. Total number of blueberries in the tub. Number of blueberries in the tub. So in this simple case, she started out with 12 blueberries in the tub, and she wants to put 2 blueberries in each dessert, and she uses this formula to find out how many desserts she makes. 2 into 12, oh, well, that's 6 desserts I'll make. So what does the constant k represent? It's the number of blueberries in the tub. Well, let's have a look at part B. We've asked to complete this table. Now, in the first column, we can see that we're given a value of B and the corresponding value of D. So let's write that down. B is 2, D is 120. And well, let's put these values into this formula. So it's 120 equals k divided by 2. Now, what can we do with that? Well, it's like an equation. Let's get rid of this divide by 2. We'd do the opposite, multiplying by 2. And of course, equations are balanced. We'd have to do the same to the left-hand side. So, to get the value of k, we multiply both sides by 2. We'll get 240 on the left. This divide by 2 cancels out with this times 2, and we're left with k. In other words, the number of blueberries in the tub we now know is 240. So in that formula, we do know a bit more about it. We know that we're starting with a tub with 240 blueberries in it. Well, let's see what part the second column is about. Well, in this case, we know B is equal to 6. And let's put B equals 6 in this, and we should be able to work out what D is equal to. 240 divided by 6. And you do have calculators, so the answer to that would be 40. In other words, we've got 240 blueberries in the tub. Each dessert has 6 blueberries in it. That means we can have 40 desserts. The last one, we've to find B. We know that D is 30. So again, let's use this formula. but this time we know D is 30. So what does that mean? Well, it means that 30 is 240 divided by something. Well, we're in an equation again. Let's get rid of this divide by b by multiplying by b. Do that to both sides. Keep the thing balanced. 30 times b. That goes. Divide by b times b, they disappear. You're left with 240. Let's get rid of this divide by multiplying by 30. Opposite would be divide by 30. So if I divide both sides of this equation by 30, we should end up with b on its own, 240 divided by 30. And again, your calculator will help you here. You'll get 8. And what that means, if we've got a tub of 240 blueberries, 8 blueberries in each dessert, and you'll get 30 desserts. Now, the one way you can check all this works, number of desserts, number of blueberries in each dessert, if you multiply these, you should get your 240, the number in the tub, and 2 times 120, certainly 240. If we've got 40 desserts, each having 6 blueberries in it, 40 lots of 6, that's 240. If we have 30 desserts, each with 8 blueberries, 30 times 8, 240 blueberries altogether. So that looks okay. So here's question 20. And part A, we're shown a spinner with 6 sections. We're told that these sections contain the numbers 5, 6, 7 or 8. Each number appears at least once, and the probability of an even number is the same as the probability of a 7 being spun. So, at least 1 5, at least 1 6, at least 1 7, at least 1 8, they appear once at least. And the probability of an even number is the same as the probability of a 7. Now, at present, that's not true. The probability of an even number will be 2 out of 6, at least. The probability of a 7 appearing is just 1 out of 6. So we need at least 1 7. Now the probability of getting a 7 is 2 out of 6, 2 sixths, and the probability of getting an even number is 2 out of 6, the 6 and the 8. If we put another 7 in there, the probability of 7 would be 3 6, and even would be still 2 6, so that's no good. We certainly can't put another even number in there, otherwise we'd get the probability of an even number being 3 6, whereas the probability of a 7 would be only 2 6. And remember, we only have the numbers 5, 6, 7 and 8 to choose from. So we said we can't have a 7 and we can't have another even number. Well, that doesn't leave us much choice. That has to be a 5. And let's just check it. The probability of an even number, well, that's only the 6 and the 8, so that's 2 chances out of 6, 2 sixths. And the probability of a 7, 2 chances out of the 6 when it's spun. So that's the completion of the spinner. There's 2 5s, 1 6, 2 7s and 1 8. Doesn't matter the order they're in, so long as that's the numbers that are on the spinner. Work out probability of 5. Well, the probability of a 5 being spun is 2/6, which can be written as 1/3 when we cancel 2 from that fraction. So 1 out of 3, 1/3 is the probability of a 5. So let's have a look now at the second part of that question. There's a different spinner. It's 10 sections and they're each labelled A, B, C or D. The probability of an A appearing is once out of 10, 0.1, one chance out of 10. The probability of a B appearing is 5 chances out of 10, 5/10, 0.5. Probability of a C appearing is 2 chances out of 10, 0.2, 2/10. And finally, the probability of a D, 3 chances out of 10. Now, that's interesting because if we look at the sum of all these, we'll get 1 plus 5 plus 2 plus 3, that's 11. The total of these is 11 chances out of 10. Now that does not make sense. We should have a total of 10 out of 10. If we look back at this spinner, you've got the probability of 2 5s, of a 5 being 2/6, of a 6, 1/6, of a 7, 2/6, and an 8, 1/6. And if you add these up, 2 plus 1 plus 2 plus 1, you'll get 6 chances out of 6, which is what you should get. This should be 10 out of 10. Total should be 10 out of 10. So give one reason why there must be a mistake in the table. The total is 11/10. The total should be 10/10. So that's the reason why there's a mistake. So here we have question 23, and in part A we're given a sketch of the graph y equals negative 2x plus 6. So that's basically a formula that allows you to work out the y-coordinate if we know the x-coordinate for any point along that line. So in particular, if we have x being 0, which is what's going on for point C, then we can work out the y-coordinate using this formula. Negative 2 times 0 plus 6. Well, negative 2 times 0 is 0, 0 plus 6 is just 6. So 0, 6 will be the coordinates of the point C, that's up here. 0, 6. Let's do point D. This time we have to work out the x-coordinate, knowing that the y-coordinate is 0. So this time y equals 0. So let's put y equals 0 there, and whatever the x-coordinate is, we know when we multiply it by negative 2 and add 6, we'll get 0. Here's an equation to solve. So let's add 2x to both sides of this equation. Now the reason I'm doing that, you'll see in a wee minute, but when we add 2x to 0, we get 2x. When I add 2x to negative 2x, that vanishes, and we're just left with this 6. So twice the number x is 6, x must be just 3. We'll divide both sides of this equation by 2. You get x equals 3. So D is the point 3, 0. There it is, 3 along, you don't go up. There's the point D. So that's the two sets of coordinates for part A. Let's have a look at part B. And in part B, we're given a sketch of a quadratic graph, and we have to complete the following statements. The first one, the value of the y-intercept, now that's where the graph crosses the y-axis. And the value of the y-intercept would be this height. X-coordinate 0, the height is 5. The value of the graph at that point when x is 0 is 5. So the y-intercept would be 5. We've also to find the x-coordinate of this turning point. Now, if we look at a diagram of this, the thing about a quadratic graph like this, it's called a parabola, and it has symmetry. And the symmetry it's got is this axis, you can see I've drawn it in faintly there, vertical axis, and it passes through this turning point. And just to show you how that works, as a colour in the left hand side, look at the right hand side, it's mirroring what I'm doing. So the graph is symmetrical about this point T. This point here is mirrored by this point here. So the -2 and the 8, halfway between them, would have the same x-coordinate as the point T. What's the value halfway between -2 and 8? And we can do that by adding up -2 and 8 and dividing it by 2. That gives me 6/2, which is 3. And there's the mirror image of my answer. So the x-coordinate of the turning point, that's 3 in there. It'll be 3. So we have a 3 there. So here's question 24. And here's Archie, who's flipping a biased coin 200 times. Now, biased would mean that there's more chance of one side of the coin turning up than the other side of the coin. There's not an equal chance of getting heads and tails. And here's information, and he's done a series of 50 flips, ending up flipping the thing 200 times. And we have to work out the best estimate for the probability of flipping a head and giving a reason for your answer. Now, we would say that the more trials, the better the estimate. So the most trials we can include would be use the 200. And how many turned out to be heads? 52. So the estimate would be 52 200ths. Now that's not the way that we usually present probabilities. Usually as a decimal, it's a number between 0 and 1, or a fraction that's cancelled down. Now you do have calculators, so you can go 52 divided by 200, but if we half top and bottom, we get 26/100. So that would be 0.26, or 26 hundredths, or 13 50ths if we cancel down completely. That's a factor of 2. Now 13's a prime number, no more cancelling's possible, but 0.26 would be a good answer for that, or 13/50ths. And the reason, the more trials, better the estimates, so use 200 trials, 200 flips. So finally, here's question 25, and we're talking here about a lion sprinting away from its den, and the graph shows the lion's distance from the den. We're asked to work out the speed of the lion in meters per second. So it's wise to use 2 points on this graph as far away as they possibly can be. Now, I would use this point here and this point here. And reading carefully on the graph, we certainly know that the time here is no seconds. That's as it starts, hasn't run any distance. And how far away from the den was it when it started running? Well, it's one little square above 25. So we've got to decide what one little square stands for. Well, there's 5 little squares make up 25, and a fifth of 25, 25 divided by 5, will give us 5. So each little square will stand for 5 meters. 5, 10, 15, 20, 25, 30. We've got 5 meters more than the 25. So this point here is 0, 30. So it starts off 30 meters from the den at time 0. Let's see what this point tells us. It tells us the lion's been running for 5 seconds. And how far has it travelled? Well, look, that's 1 square short of this 125 metre line. So 5 metres away from 125 would be 120. So after 5 seconds, it's now 120 metres from its den. But remember, it started 30 metres away from the den. So how far has it travelled? Going from 30 metres to 120, distance travelled would take one from the other. It's 120 minus 30. Now remember, you do have your calculator, so that could be worked out if you're not sure. That's 90 metres. And how long did it take? 5 seconds. So time taken, 5 seconds. So let's just write this down. 5 seconds, it's travelled 90 metres. So in 1 second, it would have travelled a fifth of that distance. We divide 90 by 5. Do that in your calculator. You get 18 metres. So the speed, that's exactly what a speed tells you, is how far it's travelled in 1 second. That's 18 metres per second. So the answer, 18. And there's metres per second. So that's Mr. Corsi signing out, and I hope you enjoyed the video.